Okay, so today we're going to look at solving systems of equations by substitution. Two examples here. First one's a little bit easier. Now the steps for this are, first I'm going to solve for x or for y. So my first example 1 here, again, look for x equals or y equals. Looking at the first example, the first equation does have y equals. Now what I'm going to do is, step 2 says to substitute that expression. So in this case, I'm going to highlight it. It's 5x minus 7. I'm going to substitute it in for y here. Okay, because they say y equals, so I'm going to substitute that, plug that in for just the y here. Everything else gets written as is, negative 3x minus 2. Now whenever I substitute something in, I'm going to put parentheses around it. 5x minus 7 equals negative 12. Okay, so in this case, what I have now is I have an equation that only has one variable. I'm going to distribute, combine like terms, and continue to solve. So my next step here is to distribute this negative 2 to everything inside the parentheses. So I have negative 3x minus 10x plus 14 equals negative 12. And now I'm going to continue solving. So I'm going to combine like terms. So in this case, I have negative 3 and negative 10x, which gives me negative 13x plus 14 equals negative 12. I'm going to subtract 14 from both sides. Negative 13x equals negative 26. Divide both sides by negative 13. And I get x equals 2. Now, a lot of times people think they're done there. However, the solution to a system of equations is a point. So right now I just have the x value. So now the last step is I have to plug this value into one of the original equations. The y equals 5x minus 7 is the easiest one to plug it into. Y is already by itself over here. Again, when I'm substituting, I'm using parentheses. And I get y equals 5 times 2 is 10, minus 7 is 3. Y equals 3. So recall, the solution has to be a point, so it has an x and y coordinate. The x value is 2. The y value is 3. So my solution is 2, 3. One more example here. If you look, I don't have x equals or y equals. So I need to get x or y by itself. I'm going to look for the easiest way to do this. If I look at my first equation here, I have nothing in front of the y. So I don't have to divide by anything when I get y by itself. I just have to do one little step to get y by itself. So if I have negative 5x plus y equals negative 3, the only thing I have to do is add 5x to both sides, which gives me y equals 5x minus 3. So my new equation is y equals 5x minus 3, so I kind of get rid of that top one there. And I'm going to do the same exact thing I did in the previous example. Y equals 5x minus 3. I have a y, okay, in that equation here. So I'm going to substitute it in 3x minus 8. Instead of the y, I'm going to put parentheses, 5x minus 3 equals 24. Everything else gets written as is. Now if you look, I don't have any more y's, so now I can distribute that 8, leaving everything else as is. That's 40x plus 24, equals 24. I combine like terms, 3x and negative 40 gives me negative 37x plus 24 equals 24. And now continue solving. Subtract 24, negative 37x equals 0. Divide by negative 37. 0 divided by anything is 0. So the x value is 0. This is not a no solution. Okay, I could have x equals 0. Now I'm going to substitute 0 into one of the originals here. So I'm going to pick the top one. Negative 5 times 0 plus y equals negative 3. Negative 5 times 0 is 0. Y equals negative 3. Nice and easy solved there. But remember, the solution has to be a point. 0, negative 3. Also, if I were to plug 0, negative 3 into both of these equations, it would give me a true equation. That's another way that I can tell that something is a solution if it makes both equations true. Okay, so hopefully this helped, guys, and thanks a lot.